Hello everyone, I am Avrujyoti again came with the new chapter chemical reactions and equation. As I have told you all before that I'm gonna teach you about some of the class 10 science chapter of CBSE board, and in this video we are gonna discuss about the chemical reactions and equations from the chemistry, that is chapter number 1. So without any delay, let's today's session. Okay, the first topic which we are gonna listen that physical and chemical changes. We all know that there is two type of changes taking place around us. That is physical, which where the changes are taking place physically, and in the chemical changes that is changed by using some chemicals, or the change is taking place chemically. What is a physical change? Physical change does not involve any chemical reactions. As I have told you before, this is taking place physically, such as melting of wax, dissolving of sugar in water, boiling in water. In such examples, no chemicals are involved. In chemical changes, the chemical changes involves the chemical reactions such as fermentation of grapes, digestion of foods, burning of paper. As we know that we have to use some chemicals to use to convert the grapes for fermentation. In the digestion of food, we also know that there are lots of process taking place for simplifying or the digestion of food. In this side picture, we can also see in the chemical change there are lots of examples such as rusting, digestion, rotting, combustion, and in physical changes, that is melting, shredding, boiling, and chopping. And in this second topic, we are gonna listen about the chemical reactions and chemical equations. The chemical reactions are the process of interaction of chemicals to form new chemicals. The chemical reactions are such kind of activity where the two or more chemicals interact with each other to form new chemicals or more compounds. That in example we can see that hydrogen reacts with oxygen to form water. Chemical equations. Chemical equations are nothing but the representation of those sentences in some formula. We all know, we have learned in previous classes also, that each and every compounds have its symbols and formula. Symbolic representations of chemical reactions that involve the use of formula and symbols. Hydrogen reacts with oxygen to form water. This we can write in chemical equations, that is H2 plus O2 equals to H2O. The elements which reacts is known as reactants. The in between those compounds where the reactions is taking place, those are known as reactants. In this activity or in this reaction, we can see that reactants are hydrogen and oxygen. These two are reacting, and the element which is formed is known as products. Like the after this reaction, water H2O is formed, so it will be a product. And I want to say another one thing, that is please note all these definitions or all these notes, as this may help in your future. Okay, the balanced chemical equation and its importance. In the third topic of this chapter, we can see that the balanced chemical equations. Balanced chemical equation. A chemical equation having an equal number of atoms on both sides of the equation is called balanced chemical equation. The both sides of the equation refers to the reactants and the products, such as H2O plus O2 equals to H2O. Here we can see in the reactants, in the left hand side, H2 is 2, oxygen is 2, but in the water, in the product side, H2O, hydrogen is 2, it is balanced, but the oxygen is 1. But in the reactant side, oxygen is 2. So let's balance this. So we can see that 2H2, that is, it's becoming 4 hydrogen and plus O2 equals to 2H2O. Here then we can see that hydrogen is 4 in the reactant side, left hand side, and the right hand side also the hydrogen becomes 4. It is already balanced in the previous one also. But in the case of oxygen, we can see that in the right hand side oxygen also becomes 2. That is, we have added just a 2, just a number 2 before the products 2H2O. Okay. Conditions in reactions. There are many conditions which are affecting in reactions or which are effectful in the reactions, such as heat, sunlight and pressure, gas liberation, catalyst, precipitation formed, physical states. We can get all the definitions of these terms later on in the next slide. Okay, so now we are going to learn some important definitions. Catalyst. What is a catalyst? What are the uses of a catalyst? Any substance that increases the rate of a reaction without itself being consumed. What is the meaning of it? The substance which speeds up the rate of a reaction without itself being consumed. A catalyst is the product or any type, any kind of something, any kind of means chemical that is put in the reactions in the form of reactants so that the rate of a reaction increases without itself being consumed. Precipitation reaction. The reaction in which precipitate forms, that is insoluble salts. In some reactions we can follow that a solid type of thing which will form in the reaction and will get settled down at the bottom of the test tube. Those solid things are nothing other than the insoluble salts, that is the salts which are not soluble in water, insoluble salts. Physical states. Carbon, that is found in solid state, plus O2, that is in gaseous state, equals to CO2. Carbon plus oxygen equals to carbon dioxide. Carbon dioxide is also in gaseous state. In this reaction, we can see only the two forms of physical states, that is solid and gaseous. But in the second reaction, we can see that NaCl, that is sodium chloride, plus H2O equals to Na plus Cl. NaCl is present in the solid form, H2O is present in the liquid form. Okay, so this term aqueous is new to us. So what is aqueous solution? Aqueous is nothing but other than the substances which are soluble in water. That means the Na and Cl which are formed in the product side, that is right hand side, are soluble in water, that is mixed up with water. NaCl plus H2O equals to Na plus Cl. Types of states: solid, liquid, gas, aqueous. There are 4 types of states: solid, liquid, gas and aqueous. Now we are gonna see there are 4 types of chemical reactions. What are those 4 types of chemical reactions? The first one is combination reaction. In this reaction, two components mixes with each other to form a compound, such as carbon plus O2, that is oxygen, forming carbon dioxide. In the right side, we can see A plus B equals to AB. That is, by combining the two compounds or the elements, that is carbon and oxygen, we are getting the combination of both, that is carbon dioxide, C and O2. Both are present in the product. A plus B, it's becoming AB. The second one is, or the second type of reaction is decomposition reaction. a single reactant decomposes to form two or more compounds. That is, a reactant is heated or electrolyzed. I know now you can't understand what a electrolysis or this we are gonna learn in the next chapter. So now we are gonna see what are the decomposition reactions. Okay, CaCO3, that is calcium carbonate, is heated to form the two compounds CaO, that is calcium oxide, plus CO2. In the right side, for the more clarification, we can see that it is given AB is divided into A and A plus B. That is, A and B are divided from each other, separated from each other. Whereas in combination reactions, those two A and B are combined to form AB. The third type of reaction is displacement reaction. It is a type of reaction where more reactive metal displaces a less reactive element for its compound. That is, in the example we can see that Zn, zinc plus CuSO4, copper sulfate, equals to ZnSO4, zinc sulfate plus Cu, that is copper. We can see that zinc displaced the copper. Copper is separated from the SO4, that is sulfate, and the zinc got attached with that SO4, zinc sulfate plus Cu. So what is happening here, as zinc is more reactive than the copper, so it has the ability to replace copper. But can copper replace zinc in other reactions? No, because zinc is not less reactive than Cu. ZnSO4 plus Cu. Okay, in the right side, for more clarification, we can see that A plus B, BC equals to AC plus B. B is replaced by the A because A is more reactive than the B. But B, as B is less reactive than the A, B can't replace A. Only A has the ability to replace B. The fourth type of reaction is double displacement reaction. In this type of reaction, mutual exchange of ions takes place between two elements to form two or more compounds. That is NaOH, sodium hydroxide, plus HCl, hydrochloric acid. By adding these two, we are getting NaCl, sodium chloride, plus H2O, water. That is, we can see that Na is going with the Cl, that is chloride, means sodium hydroxide is separated, and in the HCl also hydrogen and chloride are separated. So sodium goes with the chlorine and the hydrogen goes another with the hydroxide. That H plus OH equals to H2O. It's becoming water, and as Na goes with the Cl, it is becoming sodium chloride, NaCl. In the right side, we can see AB plus CD equals to AC plus BD. A is going with C1 and the B going with D. AC plus BD. Okay, for more clarification, I can give you a very well examples for you guys. Suppose AB is one couple and CD is another couple. A is the girlfriend, B is the boyfriend, and C is the girlfriend, and D is the another boyfriend. Okay, so the breakup takes place between these two couples, and A, that is the girlfriend of the number one couple, goes with the boyfriend of the second couple, that is A, C, and the boyfriend of the first couple going with the or came in relationship with the girlfriend of the second couple, that is BD. So I think this this example is going much easier for you guys. Okay, in the next slide we are gonna see what are the types of reactions, but this type of reaction are going to based on energy. there are two types of energy, endothermic and exothermic. By seeing the name only, I hope many of them has understood what is it. Endothermic reaction. It is the reaction in which energy is supplied to carry out the reaction. As I have told this, heated is in the previous slide, as I told that CaCO3 calcium carbonate is heated to form calcium oxide and hydrogen. Sorry, that is water. So in the same type of reaction, that means that reaction was the endothermic reaction. The heat is supplied. So in the example also here we can also see that that same example is given. CaCO3 is heated to form calcium oxide, that is CaO, plus CO2, that is carbon dioxide. So we can see that for the separation of calcium and the carbonate, heat is supplied. That means the reactions where heat will be supplied or the energy will be supplied, that will be endothermic reaction, and the reactions where the heat will be evolved or where the heat or energy will be released. Such type of reactions will be exothermic reactions. It is the reaction in which energy is generated by the reaction. As I have told before, CH4 plus 2O2 equals to CO2 plus 2. Okay, here it is given CO. Okay, that is carbon monoxide. Here we are not going to write CO2, that is carbon dioxide. Here we are gonna do is carbon monoxide. CO is carbon monoxide because mono means single and the only one oxygen is present in this reaction or in this reactant. Carbon monoxide, CO, plus 2H2O. In simple word, we can say this reaction is the burning of coal. Okay, burning of coal. CH4 is methane. The chemical name of this compound, that is CH4, is methane. That is burning of carbon. We know, burning of coal. We know by burning of coal the heat is generated. The fire excavates and it is used in many ways. The another example is respiration. Here we can, in the lower side of the page, we can see that it is given C6H12O6, that is glucose plus 6O2, oxygen, is forming 6CO2 carbon dioxide plus 6H2O water plus ATP is energy. ATP is adenosine triphosphate. It is the uh, this you will learn in the first chapter of the biology. Okay, so in respiration we get energy, we all know through the process respiration our body gets energy, and that's why we are able to play cricket, football and many other things. Okay, so let's go to the next slide. Heat can be produced in three types: thermolysis, photolysis, electrolysis. What is thermolysis? Where heat energy is produced or generated to the reactions to carry out the reaction. The same example, CaCO3 calcium carbonate is heat is generated to carbon. Yeah. Heat is generated. Sorry guys for the interruption. Uh, Heat is generated to the calcium carbonate to form calcium oxide, that is CaO plus CO2, that is carbon dioxide. The reactions where heat will be supplied, that will be known as thermolysis. I know there are many questions raising in your mind. Why? And in the previous slide we learned that where the reactions where the heat will be supplied, that will be known as endothermic. But the heat, here it is written that heat can be produced in three types. In the question it will be mentioned what you have to write, endothermic or thermolysis. Okay, if that is told that in the basis of heat generation state the type of reaction taking place, then you have to write the thermolysis, that is heat energy will be supplied. The next one is photolysis, that is light energy will be produced. Light energy, the example you can say is sunlight. In the example we can see that 2AgCl, silver chloride, is it is kept under the sunlight. In your NCERT books you can see a diagram, it is given that uh, it become the silver after keeping those plate of containing silver chloride will become gray in color after keeping sometimes under the sunlight, and also it will be separated, that is silver and chloride will be separated from each other. 2AgCl equals to 2Ag plus Cl2, that is at silver chloride becoming silver and chloride. Silver chloride becoming silver and chloride. Try to understand the sentence. Silver chloride is becoming silver and chloride. That means silver and chloride are separated from each other. The next one is electrolysis. That is electric energy will be produced. As I have told this electrolysis we will learn in the next chapter. In the next chapter we will learn the electrolysis process in the more detailed form. Till now just keep it in the mind, that is electrolysis means the supply of electric energy, that is the reactions, that means the electric energy will be supplied, the reactions will be carried out through the electric energy, that is H2O. Okay, we have seen that hydrogen plus oxygen equals to water, but do we know how to separate, how to convert oxygen again into the separation form of hydrogen and oxygen? Okay, through the electrolysis process we can see that water is again converted into hydrogen and water. Redox reaction. We have come to the end of the chapter, almost end of the chapter, not the most end. Redox reaction. Okay. Oxidation reaction. Addition of oxygen or the loss of hydrogen or electron. And the reduction reaction is removal of oxygen or addition of hydrogen or electron. The oxidation, we can call a reaction the oxidation reaction when we can see that oxygen is added to that reaction, or the hydrogen or hydrogen electron will be lost, either addition of hydrogen or loss of hydrogen. Okay, that will be known as oxidation reaction. In the next slide we are gonna see many examples. I know it is becoming difficult for you to understand with only the definitions. The reduction reaction, in this case either removal of oxygen or addition of hydrogen. The scenario changes in the reduction reaction. Here the oxygen will be removed and hydrogen will be added. That such type of reactions will be known as reduction reaction. Okay. The reaction where both oxidation and reduction takes place simultaneously. Okay, add the word simultaneously. I think it is not, or it has been missed out. The reactions where both oxidation and reduction takes place simultaneously, such type of reactions is known as redox reaction. From the reduction word we have taken red, and from the oxidation ox is produced. It is becoming redox. Okay, we can get an example of combination reactions over here. Oxidation plus reduction, it is becoming redox. Okay, jokes apart. Redox reaction. Here it is. Carbon, that is 2Cu plus O2. Okay, one thing I want to say, you all are seeing that 2 and many other numbers placed before the elements. These all chemicals are present in the balanced form. In your NCERT books, you can get in the naked form, and also you can practice. And also, I will make a separate video how to balance chemical reactions that you can get from the description box of this video about the next video, which I'm gonna make for about the how to the make about the balanced chemical equation where I will be teaching you guys how to balance chemical equation, because from this chapter balanced chemical equations are most important. Means then 40% questions comes from that balanced chemical equation. It is type of maths in physics. Okay, so in this reaction Cu plus O2 equals to 2Co. As I have told, in oxidation reaction, oxygen is added. That is, in the reactant, in the product side, we can see that oxygen is added to the carbon. Sorry, copper. Extremely sorry, guys. The copper plus oxygen equals to copper oxide. Oxygen is added to the copper. That is, copper is oxidized. Copper is oxidized. The site of oxidation where the oxidation is taking place, that is Cu is getting oxidized, oxygen is added to the Cu. Site of reduction, in the reactant side we can see that the O2 is getting reduced to form 2Cu, that is copper oxide in the product side. Oxidizing agent O2. Okay, what is agent? What is oxidizing agent and reducing agent? In the sites of reactions, the site of oxidation is known as where the oxidation occurs, and in the oxidation agent, the other element becoming the oxidizing agent for which the other element is getting oxidized. Such as in the reactants, we can see that 2Cu, that is copper and oxygen. For the oxygen, copper is getting oxidized. Okay, for the oxygen, copper is getting oxidized. So what will be the oxidizing agent? Oxygen. What will be the oxidizing agent for whom copper is getting oxidized? Oxygen. And the reducing agent, in the same way we can say that for whom oxygen is getting reduced, for whom the oxygen is getting reduced, that is loss of oxygen because of Cu, that is copper. So reducing agent is becoming Cu. Okay, we will see also we will see many other examples, many more examples, not only one or two. We will see many other examples in the next video, which I told I will make about the balanced chemical equations and the redox reactions and all. I hope in that video the concept of this reactions will get will become clear to you all. Okay, now corrosion and rust. What is corrosion? When metal surfaces are attacked by substances around it such as oxygen, moisture, acids, etc., it is said to be corroded, and this process is known as corrosion. Okay, in the picture we can see that nail became little brownish. It is oxidized and it becomes the what to say, iron oxide. In the rust one, we can see that iron is the presence of moisture combines with the oxygen from the air to form a brown colored substance called rust, that is iron oxide. Iron is one thing we have to remember, that rust only occurs in iron, not anything else. And the formula of rust is iron oxide, that is FeO. FeO, iron oxide. Prevention from corrosion. Many more examples are in your houses. The grills might be present or might not be present. In many other ways, a nail should be present in your house. Okay. And after some time, after getting in contact with the air, moisture and all, uh, this nail or iron is becoming brown in color. Okay, its strength reduces. Okay, so at that point of time, we have to change that thing. We have to change that iron nail or grill, because if that continues to be rust or corroded more and more and more, its strength will be, means nothing. Nothing will be left with its strength. So how to prevent from corrosion? Oiling. We have to rub the oil with the iron products, iron nail, grills and etc. Oiling. Painting. We have to paint. We have seen that in-house our parents instructing us or instructing many peoples to, hey, paint this gate carefully. Okay, so what does that mean? What is the reason behind it? Is it only to look the gate or to look the thing nice or beautiful? No, but also to prevent that metal or the iron from the corrosion. Galvanization. It is also a process to prevent from corrosion. Okay. Copper is attacked by moisture, which forms carbon carbonate. Okay. Silver is attacked by sulfur, which forms silver sulfide, which is black in color. As we have seen, our mother wears, or also we also wears silver chain, and after some time it is becoming black in color. So what is that? That is silver sulfide. It is undesirable as it reduces the strength and fades its appearance. As I have told before, it is undesirable. No one wants uh, to lose its or to lose the product strength. Okay, as it is harmful for the product. So no one wants. So it is undesirable as it reduces the strength and fades its appearance. Rancidity and its prevention. What is rancidity? The taste and odor of food material containing fat and oil changes when they are left open in air for a long period of time. In the picture, we can see that the bread or the sandwich is in horrible condition. Why is it so? Because it is left over in the air for a long period of time. The moisture acted with it and forms the rancidity. So obviously the taste and odor of food material changes. The fats and oil actually reacts with the moisture, and you can see in the picture how it is becoming. It is in the horrible condition. Please don't try it this home and don't consume such type of things. How to prevent foods from rancidity? By adding oxidants to the food material, storing food in airtight container, using flush bags with nitrogen gas. Okay. Uh, hmm. Sometimes we are instructed, or sometimes we carry our tiffin in the airtight container tiffin box to the school. Why is it so? So that it doesn't get spoiled, so that it doesn't come in contact with the air so easily, and the if it happens so, the whole food will get what to say, will be destroyed, and the obviously the taste and odor will also be affected. Then you can't consume that food. Storing food in airtight container. Okay, what are oxidants? Oxidants are some chemicals which are added to the food materials to prevent foods from rancidity. Using flush bags with nitrogen gas. Okay, flush bags with nitrogen gas, chips, Lays, and many more. Uncle chips, Lays, Max. Okay, inside we can see that if we take a chips packet, the air is filled inside it. Okay, that is nitrogen gas, not oxygen or carbon dioxide, but the nitrogen gas to prevent that food, because we all know uh, that chips are made long days before and we consume it after very long days. It takes time to transport and all. So it is necessary to keep to prevent the food from rancidity. Okay, so that kind of packages are called flush bags. Okay, so yeah, we have come to an end of this chapter. Thank you. I hope this chapter becomes clear to you, and I hope that if any problem arises, you will let me know in the comment section. And one thing to say, I'm really, really, really sorry for the mistakes I have done in this video. As you all know that this is the first video. This is my first video, and I was very nervous. Not only I am very nervous. How you guys will react. I hope you guys will support me, and day by day I will try to improve myself. I know I have done lots of mistakes. As I told this, I was nervous, I am nervous, so I will try to serve better day by day. And if you like this video, don't forget to like and also subscribe this channel to get all those future uploaded videos. Stay tuned to this channel, and I will give the link of that next video in the description box so that you can reach to that video easily, where I will be teaching about balanced chemical equations, redox reactions. Okay, thank you. Bye bye.